The distance between two planes. For a plane with equation n1x plus n2y plus n3z equals d, then the distance of the plane from the origin is the absolute value of d divided by the length of the normal vector n, where n is n1, n2, n3, the coefficients of x, y, and z in the equation of the plane. It's fairly easy to prove that, I think. Let's just sketch a quick picture of the plane. So this is pi with equation n1x plus n2y plus n3z is equal to d. Now don't forget, d is actually equal to the vector n dotted with any arbitrary point in the plane that we like. Let's say OA. So there we should add in an origin, and then so A is some point in the plane, and then n is our normal vector that sticks straight out of the plane. Alright, but notice that we can choose A arbitrarily, so it doesn't matter what point A in the plane we choose. We're still going to have this real number d is equal to the normal vector dotted with that point. So let's make a different choice of A. Let's instead go further along the plane, or equivalently move the origin over here, it doesn't really matter. And let's choose our point A such that the vector OA is parallel to our normal vector n. So OA is equal to some multiple of n. Let's say k times n. Which would mean that the length of OA, which is the distance of the plane pi to the origin O, so the length of OA is equal to the absolute value of k times the length of n. And meanwhile, we also have that d is equal to n dotted with OA, which is k times n. And so we can factor out the k, so this is equal to k times n dot n, which is equal to the length of n squared. And so clearly the modular, or the absolute value of d is equal to the absolute value of k times the length of n squared, and therefore the length of OA is equal to the absolute value of d divided by the length of n. So that proves the first part. Let's continue reading. So, to find the distance between two parallel planes, you can find both of their distances from the origin and then compare. Note that for two parallel planes, their n1, n2, and n3 values will be the same because they have the same normal vector. If a vector n is normal to one of the planes, it has to be normal to the other if they're parallel. Or we could say or one multiple of the other, but you can just take the equation of the second plane and divide it by whatever the n1, n2, and n3 are, a multiple of the first n1, n2, n3, and then you can arrive at the same n1, n2, and n3 coordinates for both equations. Alright, but that's not the main point here. The main point here is that after we've done said multiplication, so we got the same n1, n2, and n3 coordinates in both of our planes, if the d values are the same sign, then that means they're on the same side of O. But if the d values have different signs, they are on opposite sides of O. So if one of the d values is a positive number and the other one's negative, that means the origin is in between them. But if both of the d values are positive or both of the d values are negative, then that means they're both on one side of the origin. Let's go ahead and investigate that a little bit. So suppose we got two parallel planes, pi 1 and pi 2. And let's say they have equations n1x plus n2y plus n3z is equal to d1, and n1x plus n2y plus n3z is equal to d2. And suppose both the planes are on one side of the origin like this, then let's go ahead and project our normal vector up like this. And suppose it intercepts the first plane here at A, and then it intercepts the second plane here at B. So let's say that OA is equal to K1 times our normal vector n, and OB is equal to K2 times our normal vector n. Should probably label that this is O. You know what, I made this more confusing than what it needs to be. I'm going to relabel these subscripts of K, and I'm going to call this one K2 and this one K1, simply because A is in the plane pi2 and B is in the plane pi1. And now we can observe that actually D1 is equal to the normal vector n dotted with any point in the position vector of any point in the plane pi1. Well, one such position vector is OB, and that's equal to K1 times n. And so D1 is actually equal to K1 times the length of the vector n squared, or n dot n. Similarly, D2 is equal to n dot K2n, which is equal to K2 times the length of n squared. And clearly, if we have the origin on one side of both of the planes like this, then K1 and K2 have the same sign. So that means that D1 and D2 have to have the same sign. On the other hand, if instead we had the origin in the middle like this, then this would be K2 times n. This would be K1 times n, and we would have K1 and K2 have different signs. Which would mean that D1 and D2 had different signs. And I think from here it's pretty easy to see what to do. I'm going to go ahead and call this point A prime and this point B prime. In the first situation, if we want to find the distance between pi1 and pi2, distance between pi1 and pi2, so this is the situation where the origin is on one side of both of the planes, then that's clearly just going to be equal to the length of OB minus the length of OA. So it would just be, the absolute value of K1 times the length of n minus the absolute value of K2 times the length of n. So it would be the absolute value of K1 minus the absolute value of K2 times the length of n. Not particularly complicated. In the other situation, when we have the origin in the middle, like that, we would have the distance between pi1 and pi2 is clearly equal to OA in the length of OA plus the length of OB, the length of OA prime plus the length of OB prime. And so that would just be it would be the modulus or absolute value of K1 plus the modulus or absolute value of k2 times the length of the vector n. So that's how to find the distance between two planes. You have either the origin on one side of them, or the origin is in between them. There's no other possibilities. And you can tell which case you have depending on whether the values of d1 and d2 are the same sign. Notice that it only really makes sense to find the distance between two parallel planes, so that probably should have been included. Parallel planes. If the planes are not parallel, then they're going to intersect along some line. See if I can draw a picture of that. I don't know, maybe it looks something like this. So they intersect along that line. Pretty horrible picture, but well, yeah, that's just awful. The point is they're going to intercept along a line if they're not parallel to one another, and that means that the distance, well, the shortest distance between any 2 points is 0. It's where they meet. Meanwhile, the longest distance will be, I guess, infinite. So yeah, when we're finding the distance between two planes, we want to find the distance between two parallel planes.